Let us see what are the characteristics of sound. They are wavelength, amplitude, frequency, time period, speed, loudness, pitch, quality or timbre. We will discuss them one by one. Wavelength. Let us understand what is meant by wavelength. Wavelength is the distance between two consecutive crests or troughs. Wavelength is represented by Greek letter lambda. SI unit for wavelength measurement is meter. Here we will discuss about amplitude. Amplitude is the maximum distance a vibrating body or oscillating body moves from its position of rest. We can understand this by the example of a simple pendulum. Let us recap the simple pendulum. A simple pendulum consists of a bob of mass m hanging from a string of length L. It is fixed at a point P. Pull the bob to one of the ends, say A, and leave it. The pendulum starts oscillating from the point A to B and then to C, and it comes back. The point B is known as the 0 point of the pendulum. Here, amplitude is the maximum distance travelled by the bob of the pendulum on either side. That is, distance AB or CB is the amplitude of the pendulum. This is the same for any vibrating body. Let us discuss about the next characteristic, frequency. Frequency is the number of oscillations per second. It is denoted by the Greek letter nu. Its unit is hertz. Frequency is the reciprocal of time period. If nu is the frequency and t is the time period, then nu equals 1 by t. Here we will discuss about time period. Time period is the time taken by the vibrating body to complete one oscillation. Time period is represented by the letter T. The SI unit of time period is second, S. Consider the previous example of the simple pendulum. Pendulum is said to complete one oscillation when the bob of the pendulum travels from point A to point C and then again to point A. Or we can say that one oscillation equals BA plus AC plus CB. We can measure the time taken to complete one oscillation using a stopwatch. Pull the bob of the pendulum to one end and release it. Pendulum starts oscillating. Now start the stopwatch. Notice the time taken to complete 20 oscillations. Time period can be calculated by dividing the time taken by the number of oscillations. So time period T equals time taken divided by number of oscillations. Suppose the time taken for 20 oscillations is 20 seconds. Then T equals 20 by 20 equal to 1 second. Speed. Here we will discuss about the speed of sound. Speed of sound is the distance travelled by the time taken. Velocity or speed of sound is represented by the letter V and time by t. So V equals S by t. Its SI unit is meter per second or m by s. Velocity or speed of sound varies in solids, liquids and gases. Speed of sound in dry air is 332 meters per second, and it varies depending on the humidity of air. Speed of sound in humid air is 400 meters per second. Speed of sound in water is 1450 meters per second. Loudness. Loudness is the measure of sound energy reaching the ear per second. Unit of loudness is decibel, dB. Let us understand this by an example. Strike a drum gently. Listen to the sound. Sound produced is soft. Again strike the drum hard. Now the sound produced is loud. What do you observe from this? When you struck the drum gently, you applied less energy. So amplitude was small and soft sound was produced. But when you struck the drum hard, you applied more energy. So amplitude was more and loud sound is produced. Hence, we can conclude that loudness depends on the amplitude of the sound. Different sounds have different decibel values. For example, whispering has a decibel value of 10, which is the lowest volume heard. Talking has a decibel value between 30 and 40. Moving car produces a sound of decibel value between 60 and 70. Motorcycle produces a sound of decibel value between 90 and 100. The sound of thunder has a decibel value between 120 and 150. Sounds having decibel value above 80 is called as noise. Example, motorcycle, thunder, etc. Pitch. Pitch of sound enables us to differentiate between different sounds. Listen to the sound of child.
Hello.
Then listen to the sound of a man.
Hello.
You will be able to distinguish between the sounds without seeing them. How is this possible? This is because the sound of the child is of high pitch than of the sound of a man. So, we are able to distinguish between them. Pitch of sound depends on the frequency of sound. That means it depends on the frequency of vibrations produced. Let us understand this by a simple activity. Keep your bicycle upside down on its saddle. Hold a piece of soft cardboard so that it touches the spokes of the back wheel. Move the wheel. The wheel rotates. The spokes of the moving wheel touches the cardboard and it vibrates. This produces a sound of low pitch. Now move the wheel fast. The wheel rotates faster and a high-pitched sound is produced by the cardboard. What do you think is the reason for this? This is because when the wheel rotates faster, high-frequency vibrations are produced. Hence, high-pitched sound is produced. When the wheel rotates slower, low-frequency vibrations are produced. Hence, low-pitched sound is produced. So we can conclude that pitch of sound is higher when the frequency of sound is higher. Dependency of pitch of sound. Pitch of sound depends on the length of the vibrating body, for example, guitar, tightness with which it is stretched, thickness of the vibrating body. Quality of sound enables us to differentiate between sounds of different musical instruments having same pitch and loudness. Listen to the sounds of flute and trumpet. we can differentiate between the sounds without seeing them. Quality of sound depends on the shape of the sound wave. Here, the sound waves of flute and trumpet look different, so their quality also differs.